Good morning, students. Today we continue lecture part of Medical Informatics and Biostatistics course, and we have fifth lecture, but in fact we have to complete material which is related to lecture 4, which spoken about various biostatistical methods which could be applied with various fields, including biomedical scientific research. And only after that we will move into question related to usage of information systems, information technology, other kind of information technologies in medicine and healthcare. So previous part of lecture 4 had been dedicated to very wide question related to statistical hypothesis testing. So right now we move further with other methods which is useful for application of statistical techniques for biomedical research. And here is we will consider one of available methods which is related to identification of possible relationship between various variables, which is a correlation. So, as I said, it is statistical techniques that can show whether and how strongly pairs of variables are related. The measure for implementation of correlation or objective of correlational analysis is to calculate correlation coefficient, which range from -1 to +1 for ideal case, which dedicate ideal positive or negative correlation, and so close coefficient of correlation value for to +1 or -1 is more closely to variable or related. And if you want to identify in general relationship between variables, squared value of coefficient of correlation have to be used, so-called coefficient of determination, which show percentage of variation in a very dependent variable y, which is explained by all the x independent variables value together. Practically, two main types of correlation coefficient could be used depending to data types and distribution type of our sample data. So Pearson or product moment correlation coefficient, when we attempt to use it, we expect that variables are normally distributed and we deal with continuous variables. So both independent and dependent variables are continuous. And Spearman-Rand correlation coefficient appropriate when variables are skewed or ordinal and is robust when extreme value are present. So when we have deviation from normality, from normal distribution as well. More about this you can check by given link when we will open PDF page. So what I want to sign that it's correlation, it's only one of methods which could be used for identification relationship between variables. And also it's even general part of biostatistical analysis. So if you will check this flowchart, you will see even previously method which we considered previous time about hypothesis testing, and they are ought to be considered together depending to number of variables, depending to distribution type, and depending to goal we want to achieve. So here is where is correlation placed within all statistical methods. And for sure, manually, we can calculate both Pearson and Spearman's correlation. Here is at left side shown how they could look like. Here is in that area. For sure, we can use various IT solution like application. Various application could be used for calculate, for perform correlational analysis, especially spreadsheet. But also before even we will proceed with analysis, it's important to remember rules, how to interpret coefficient correlation value, because in fact it's like probably should never happen that you have ideal correlation. Practically, we have correlation could be rated from high positive or negative, depending to sign, to negligible correlation, like proposed in this work. So please check this source as well. If we want to use spreadsheets like Microsoft Excel or LibreOffice, OpenOffice, Google Spreadsheet. So here is we have predefined function which implement typically Pearson correlation only. So you have to be sure that your data is normally distributed. And for example, how ideal correlation could look like. Positive in this area and ideal negative correlation in right bottom corner. So as you can see, have to be obvious that positive correlation means that both independent variables incline decline simultaneously. And when we have ideal negative correlation, or close to ideal negative correlation, we have like mirroring between dependent and independent variables. One incline, second decline, and so on. In addition, Excel spreadsheet as well as Google spreadsheet give for us correlation tool, which also implement a Pearson product moment correlation, but allow to create a relationship between multiply variable, identify correlation between multiply variables at a time. So in fact, it's only give for us matrix of all possible paired correlation, because in fact, correlation method itself, it's identification possible relationship between two variables and no more. And if you have three variables, so maximum that you can, it's three independent coefficient correlation between all possible pairs, and so on. So here is shown exact example, and later I will show short example, practical live example about this. Next question, regressional and next statistical methods, which is applicable widely. It's regressional analysis, and it's one of its implementation, it's curve fitted. In general case, regressional analysis, it's a set of statistical methods used for estimation of relationship between independent variable and one or more independent variable. Actually, it's further extension after we already proved that they are correlated, and with regression we have aim to provide evidence that to explore this features and these characteristics, and mostly it could be used for prediction, for forecasting. So with regression analysis, we have ability to build mathematical model, reconstruct mathematical model which fit our data, and make this model for prediction. And one of the useful method, so first of all, for sure, we can use various analytical approach to reconstruct mathematical model analytical, but also we can use column fitting. That's process of trying to find the curve which represented by some mathematical model, so which best represents the sample data. So where we have sample data which is random fluctuation, we can look in for mathematical model with specific parameters which will look like visually as much possible closed, and which will have minimal deviation from our experimental data, which is based on coefficient determination from correlational analysis. Conventional model just recaps school material. It's like linear, logarithmic, or power exponential, or even polynomial model with multiply coefficients. So in fact, aim of regressional analysis, all methods of regressional analysis, especially curve fitting, it's looking for all those coefficients for this equation, which will make model mostly as much possible closer to our experimental data. In fact, we can create, especially if you talk about preliminary model, up to 6 order, up power of 6 with a spreadsheet like Excel or so. But with such large and great power level, we have an extremely risk of overfitting when model will demonstrate extremely good likelihood to our experimental data, but will be almost absolutely useless for forecasting. So we will concentrate a little bit more on Excel trendline features because practically you will use most times these features in only one attempt of analytical prediction you will make with forecasting function, which implement linear model in fact. So with color fitting, you have to draw proper chart, which is in case of continuous data and time series analysis data, it will be almost definitely it's have to be XY scatter plot chart, and then you have to add trend line for your necessary type of trend line to your data series, and visualize model and visualize coefficient of determination or a square value. So here is given all the things in details. Here is mentioned about usage of linear chart time. Sometimes it's allowed to use linear, or at least sometimes linear chart will produce exactly the same model like XY scatter plot, but every time it's have to be used with caution and if possible, try to avoid linear in favor to scatter plot. A modern Excel spreadsheet provides the following settings for trend line. You can like add trend line to your data series. You can identify type of trend line you want. Especially you can even provide additional settings like order for polynomial trend line. Here is immediately possible to create a visual prediction with forecast option. And third area at the bottom, most important, it's give for us equation and a square value, which we have to be used to, must be used to assessment quality of our model. So in this case, as you can see, polynomial third order demonstrate very high quality, coefficient of determination is very closely to 1. So we have very strong likelihood between this model data and experimental data. And as you can see, even visual, we have it look like similar tendencies. And what is very important, that's our estimated forecasting, like continue our given line visually. In fact, we're not sure about seasonal trend because our data are actually too short. It might happen that we will have turning point somewhere here and we could have seasonal trend where experimental data would be increased. We don't know right now. Based on this, we can only assume that polynomial third order demonstrate extremely good quality of model. Okay. Before, here is look like how various trend line fit in other experimental data. And actually it's almost all about brief introduction into regressional analysis. I'm almost omitted a topic about deseasonalization because it's significantly complicated and we are slightly short in time for topic number 5 of lecture. So right now I will demonstrate just few practical examples. Okay, so here is we have for correlation. For sure we can visually make some initial assessment with conventional chart, which is actually not quite scientific approach, but we can insert linear chart just to justify visually is it correlation even possible or not. So could be, but if we want to make a really visual assessment on and identify correlation between variables with chart, again only XY scatter could be used in this case, because it's by definition this type of chart provide relationship between independent and dependent variable. And here is we can even use trend line to get coefficient of determination, linear trend line every time, which give for us coefficient of determination, which demonstrate deviation for y variables depending to variability in x. Again, it's not coefficient of correlation, it's coefficient of determination. Would be important to understand that if you will try to create chart XY scatter for 3 variables at a time, you will have only chart which will give for you correlation between x and y and x and z, but for example not about y and z in this case. And if you want to visualize this correlation, you have to create one more chart to visualize YZ correlation on the arrow. And as I can see, I have 2 data series, so 2 trend line required in this case to get coefficient of determination for different variables. And finally, if I want to get visual correlation, so I have to use one more scatter plot to visualize y to z correlation. And as I already said, Corel function is extremely easy to be in use. I have to just provide 2 variables range and I will get my value. And it's the same, exactly the same way I have to calculate correlation of analysis via data analysis toolbox. So this time I can use all 3 variables simultaneously. My samples directed in columns, they have labels in first row. And I want to print my output starting from this cell. So in this case, I have all 3 possible paired correlation, x to y, x to z, y to z. And it's obvious that we have like high positive correlation for x and y, and negative from x and z, and only even less than moderate low correlation between y and z, almost negligible correlation between y and z, almost negligible negative correlation between y and z. So here is we have how it's possible to be implemented correlation of analysis with spreadsheet. What is important to add that I have already omitted testing about distribution type. Before you will even start correlation of analysis, you have to check distribution type. Is it your sample data fit normal distribution or not? And depending to this, you have, so I assume that it's normal and use Pearson product moment correlation. Other hand, you will have to use only Spearman rank correlation and calculate only manually, and correlation of analysis toolpath will be useless for you. But XY scatter plot still could be used. Regarding regressional analysis, it's almost exactly easy as you said. So first of all, I will show how it's possible to use, I think, first of all, I can try to make forecasting by using analytical approach with forecast function, forecast ETS function, which is include possible to be providing seasonal trend identification. So first of all, I have to use target date. In this case, as date, I have used just time interval, time number. It could be minutes, hours, months, no matter. When we talk about regressional analysis and application for time series analysis, we assume that we are not interested in current date, but in the time interval. So specific timestamp not significant. Significant is interval between observation. So here is I have to use target date or target interval numbers, then noun, my noun value, dependent variables, then independent variables. And if I have suspicions that I have some seasonal trend, I add the force parameters. I have to close my brackets and Control-Shift-Enter to insert array, so-called array formula. As you can see, it's involved curly brackets, and I have prediction in by two values by two ways. So it's one way. Second way, it's for sure implement by using color fitting, like I said in lecture. And here is again, I will build scatter plot as usually, and I will add the thread lines. So here is this time I can add the multiply thread lines with linear model, which have to be similar results to given forecast TS. And even I can make immediate forecasting forward to period and visualize my linear equation, which I can use to calculate my further value. Or same way I can add the much more thread line. For example, I can add the polynomial, especially set order. I will add them to demonstrate difference. So here is, as we can see, and I will add the one more thread line. For example, exponential, or no, logarithmic would be better in this case, because even a little bit closer to our case. So, as you can see, we have three thread line, and when we just examine coefficient of discrimination, it's safe for us that again, polynomial third order provide extremely good fitting for our experimental data. But look how different direction of forecasting is. So actually, with despite polynomial third order provide extremely good quality of cover fitting, we have a significant risk of probability of overfitting. So we're not sure is that our process development will follow polynomial third order model. It might happen that we will need maybe identify seasonal trend or even use this plateau area, which is almost linear, to create another prediction just by this part of our data. So really, in reality, identification of model and dealing with time series analysis, it could be complicated process, and actually even method which is I mentioned about regressional analysis now enlisted under machine learning techniques. So other way, when we're speaking about regressional analysis, we can talk about implementation of machine learning methodologies already. So question is unclear. Answer could not be definitely clear about which model best fit our data. Technically, it's polynomial third order, but linear model also could be applied in this case. So if we want, we can implement both of it, and for example, we can implement this model just by calculating exact numerical value for further periods by using linear model. What is interesting, despite I thought forecast TS function also implement linear model, but I have introduced seasonal trend, and we have slightly different result for conventional linear model obtained by cover fitting. And even you will, let's say, absolutely another prediction value when you will implement logarithmic or polynomial model. In fact, all these three models very likely to be closer to for the project, what in this case, spoken about sales development. Another very wide application of this methodologies, it's prediction of spreading of global epidemic like we have now with the COVID pandemic. And to complete this question related to correlational regressional analysis, I just move into few, and I want to demonstrate few pair of examples, how important to proper select chat type, because depending what exact value you have used, for example, in your data set, is it's like we have measures, we use exact dates, or we use interval numbers, our model could look like differently and could have different representation. So if we will deal with exact dates, and especially if interval is irregular, here is we have line chart for compare and spreadsheet for compare. So as you can see on the line chart, X is considered automatically based on data type and has been used months as regular single months as interval for observation. And here is we have gap in our data. Check this, please. Despite we have value for just with irregular interval, it's more accurate with usage of scatter plot. In this case, we have numerical representation of our date value. So if you are forced to use exact date value, it will be only correct use scatter plot. Similar situation when you are allowed to use interval. Again, if measures interval is every time the same, like one period is the same, no matter seconds or months or so, here is almost no difference between, will be no difference between line and scatter plot usage. But also we have situation like given, when we have different interval, when we have omitted one interval, and we have one interval twice as long as our other. So again, the only scatter plot will give for you correct result. Keep in mind this every time. So if possible, try to use scatter plot. Okay, let's back to our question, and last theoretical question for topic 4. It's introduction to optimal management problem solving by example on transportation, transshipment, assignment models. In fact, we will consider only transportation problem. Transshipment and assignment, it will be out of scope because it will take too many times. So methodology is dedicated to solving, as I already said, optimal management problem, and the mathematical background is implementation of linear programming methodologies, which is under linear programming. We have to understand not exact programming languages and programming solution, but algorithms for solving a system of linear equation. So with this scientific approach to solving optimal management problem, especially transportation and assignment problem, will be based on creating a series of linear equation and solving it by given algorithm. As about possible applications, there is plenty of it with different engineering and management areas. And for sure, in case such as we have significant merging of various engineering, electrical engineering, electronics into healthcare, and also, in fact, healthcare very tightly related with various management problems like scheduling, etc. So here is we have large areas for implementation of optimal management problem solving, with mostly within administrative aspects of healthcare system functioning. So, as example, I will consider transportation model, which is simplest and very fine described and developed. So its idea is problem of distribution of goods from several points of supply to number of points of demand. And arise when cost-effective pattern need to ship items from origin to have limited supply destination. So when we want to provide optimal filling with resources, again, very conventional case, it's when we want to distribute our limited resources of, for example, various medicines or pressurized oxygen in case of such pandemic like this global with COVID. So here is a nice example how we can stress logistics and manage with optimal resource usage. So related to it, problems which could be extension of a transportation problem, it's transshipment problem, and we have multiply middleware points when not we have direct connection with customer and supplier, but we have various intermediate positions. And the third case, it's assignment model when we talk about creating various schedules, like assignment peoples to projects, physician to their working hours and duties, students and teachers to classes. So despite it look like absolutely different things to compare to transportation problem, exactly the same mathematical methods could be applied depending to which resource, depending to circumstances we have. Again, same objective, it's minimize total cost, total time of performing task at hand. That maximizing objective is also possible. So, mathematically, if we will try to redefine both this task, transportation, as well as assignment problem, with transportation especially could sound like we have M sources with each source has given supply capacity S of I, and we have N destination. Each destination provides their demand for some sources like medicines, oxygen, or so on. So J destination has D from J requirements, and our goal minimize total shipping cost of supplying or minimize time for delivery. It's also could be essential, especially in case of some vital resources like, again, that I can mention again, oxygen during COVID pandemic. So not only cost, but also time, delivery time could be managed with this kind of task. There is two major kind of transportation model available: balanced transportation problem, where most of mathematical solution provided for this case. Here it sounds like we have equivalence between our resources and the request. So total resource equal total request, total demand. So balanced transportation problem, or our task past feasibility condition. It's passed through. In reality, it's almost never happened, but for mathematical assumption, we could use it and we could create some effective solution. And here is example how like we deliver some units of pharmacy packs, from medicine packs or so. especially question, and what we have to do if we have various types of medicine to deliver, various packs, form of production, and so on. No problem. Some uniform units could be used, or weight or volume, and it's actually approach which typically applied by any delivery company. We just replace specific units for this stuff with its weight or volume, and that's all. And here is this case we can create optimal solution for any kind of stuffs we want to have to be delivered. So here is example of balanced problem when total resource equal total requests. So our question will be to create series of linear equation which will represent limitation for this task. So every time also have to be done transportation cost per unit or transportation time per our destination, for example. And here is we will be able to create two optimal solutions. Mathematically, our objective function will be given here at the top when we want to minimize total shipping cost from our source point to our destination point, and this could be represented in this manner. And here is we have x, its number of inches have to be supplied from ith factory to G warehouse or a drugstore or so. And here is we have how they are labeled. And objective function contain all possible combinations. We don't know at the beginning which one will be optimal. And then health question is to create like limitation, like flow in, flow out. We have to take everything from our source, from factories, and deploy everything to our customers, destination. So here is given equation which will represent this action. And same situation for demand. How it will be look like? We have to fulfill demand for each components. And final layout, how it could be used in spreadsheet. It's have to be look like this one. When we create a central area, it's our transportation plan. Initially, it's filled with 0. Then we provide flow out, flow in, our transportation cost, some products which in fact it's multiplication of matrices, transportation cost matrix by transportation plan matrix. So initially it will be everything returns 0, and once we provide our constraints or limitation like this one, and a special tool available under data analysis in spreadsheet called solver, which could help us with implementation of linear programming. In fact, it could be calculated manually, but it's a significant amount of time required for this, and you can check practical class material for topic 11, which give for you exactly methodology how to do it manually. Practically, we will use only solver, which is only contain our target cell, which is equal to our point to our objective function we want to minimize, maximize, then our objective minimization of maximization, then what we can alter, it's our transportation plan, here is given area, and list of constraints like flow out have to be equal flow in, and it's actually almost exactly all we need to get this transportation plan. However, in reality, almost every time we have situation when feasibility condition will be broken out. So almost every time it will be we have our extra resource. In fact, it's a very good situation when our resources are greater than our demand. In this case, we just introduce dummy destination point, which will utilize that extra resource with 0 transportation cost. It's like nothing transported, just left for tomorrow's supply iteration, and we will deal with this. But Much worse situation we have when we have less resources than we need to, and it's typical situations that again could be seen with current pandemic, when every time with next wave, most of countries, hospitals within those countries every time struggle with lack of supply, lack of medicine, lack of beds, rooms, personnel, and so the lack of almost everything. And here is what we have to do this. So for sure, mathematics give for us possible solution. We can introduce friction resource, and we can, let's say, still mathematically optimal solution, which will in reality means that if it doesn't have enough resource, so we can't fulfill our demands. Just question is who will, let's say, more, who will, let's say, less from their requirements. So as they are noted, that every time penalty will be given, but so we could have, let's say, a solution which will be sounds like optimal, which will be more or less far from optimal solution. Anyway, still we have ability to achieve positive results, like we have introduced dummy resource in this, like shown in this case. Here is we have like lack of resources, demand greater than resource, so we introduce like dummy frictional resource. Mathematically we can say this: imagine we have extra resources and we provide it with one row, we provide again dummy cost, which is again 0, nothing transported because it's not available in reality, and then we have all necessary condition already met to pass through solving solution. And here is we can achieve this with solver settings, like again necessary settings we have and possible result obtained, despite, as you can see in this case, such as we have 20 units assigned to force pharmacy. So in this situation, this one pharmacy will, let's say, less than other will be fulfilled with their demands, and this one will, let's say, less, or hospital. So, but there is no choice. Okay, actually, it's what I have to talk about. Brief introduction into correlational regressional analysis and even optimal management task solving, and we will move into lecture 5 in second. I will just switch our recording option.